Good morning, everyone, and thank you very much for joining today's event. My name is Theodoros Papalas, and as the chair of the Early Career Chemical Engineer section of the European Federation of Chemical Engineering, it's my pleasure to welcome you to our very ever first coffee talk, which is part of a series of webinars that our section is organizing. A little bit of background, the coffee talks are meant to act as a bridge between our section and the different working parties of the EFCE. And the idea is for the working parties to have the opportunity to introduce themselves and explain a bit the fundamentals of their topic and also describe the activities that they are leading. And today we are very happy to kick this off by having our coffee talk with the Working Party on Crystallization. And this task force has been led by Alper Koyuncu, who has been a board member of our section for the last 2 years. And he's with us here today, and he will serve as a moderator of the session together with Sena Altun, who is also a general member of our section. At that point, I would like to mention that this meeting is being recorded, and at the end, it will be uploaded in our LinkedIn channel. And with that, I am very happy to pass the floor to Alper to start this event, and I'm looking forward to see how it goes. Alper, the floor is yours.
Thank you. Hello, everyone. I'm Alper, and I'm also the lead of the Coffee Talks event. And let me share the. Could you see my screen right now?
Yep. Yes.
Yeah. Right. Let me. Yes. Today we are hosting one of our working parties under the EFCE, and this working party is Crystallization Working Party. We are hosting 2 speakers from this working party, both from industry and academia. Professor Daniele Marchisio is a professor at Politecnico di Torino, and also he's the chair of Crystallization Working Party. And also from industry part, Dr. Elodie Verdurand. She's the principal scientist of salt processes at DSM Pharmany and head of salt technology. If you have any questions related to meeting, you could use the Q&A box at the bottom. And also, if we are out of time, you could ask our questions on LinkedIn webpage, since we appreciate our speakers that they will respond to your questions after the meeting as well. So let me give the floor Dr. Elodie Verdurand for his presentation, and our structure is composed of 3 parts. The first one is presentation, which is composed of 10 minutes, then interview, 15 minutes, the questions from our society, EFCE Early Career Chemical Engineers, and then we will continue with your questions, Q&A part, in 5 minutes. Yeah.
Yeah, okay. So yeah, thank you very much for this introduction, and thank you for organizing this event. I think it will be an interesting event for sharing and getting to know and presenting our working party. That's a great opportunity. I will start by sharing my screen, and hopefully it works out. Yeah. There, can you see my screen?
Yes.
Yes.
Yeah, and I will switch to presenter mode. Okay. Yeah, I will start with trying to give a rough definition and relevance for industry of what crystallization is, and also why it's relevant to keep contact with academia, and so being part of this working party, and because it's a field which is in constant development. So to start with, a short, I'll use my pointer, a short definition. So crystallization is one of the separation and it's a separation and purification step. And very often it's also a way to generate solids in powder form. You can categorize crystallization in this way. So there are crystallization from suspension, or some people will, from solution, sorry, or you can refer to it as suspension crystallization, or crystallization from the melt, which will not generate solid, but is a separation and purification technique. It has relevance in many industries. The first development of description of mechanisms and process development were mostly made in the 70s, 80s through mainly by the bulk chemical industries, who needed really high yields and optimized processes to the maximum. But it's also highly used in the fine chemical and agrochemical industries. And I think in the last 25, 30 years, pharma industry has been also contributing a lot, because when you generate crystals, you can generate crystals with different crystal structure, and they have different properties in the end. So you can tune the properties of your product, and that's for patent and for market, that's an advantage. And lately also we see a lot of contribution from batteries industries. You can use crystallization in polymer recycling and also waste treatment. So it's really broadly used. Now, if we go into the fundamentals of crystallization, for those who have no idea how that would work, there are a lot of things going on during the crystallization. If we look at the mechanisms which can occur, there's first nucleation, so the formation of the first crystals, then growth. They can grow, they can agglomerate, they can break, or they can transform. So you can have the molecule which is in the crystal lattice arranged differently, and those are two different forms, and they can transform during the process. For the crystallization process itself, there are different ways to use. You have cooling crystallization, evaporative crystallization. The most known and oldest one is the formation of salts at the sea, so recovering salt from the sea. Anti-solvent crystallization, you can use a pH shift, or reactive crystallization, or you can use combination of the above, depending on what you want to achieve as your product. And there are many influencing parameters. So the solute concentration, the solvent type, the impurities of the process, and the process conditions can be used to tune what kind of solids you will get at the end. So mixing, temperature, rates, depending on which process you are using, residence time if you're working continuously. And here are some examples. This is on the left-hand side. This is the same product with the same starting composition, but two different operating conditions, two different process conditions parameters, and you end up with completely different powders. This is the most simple one, is a cooling crystallization. And if you use a concentration temperature diagram, you have your solubility curve. You start at high temperature, cool down until you nucleate, and one relevant parameter is the supersaturation. That's the difference to the equilibrium. That's the driving force. That's the ratio of the concentration in the liquid phase to the solubility at that temperature. And this supersaturation will drive all the kinetic of nucleation, growth, and all the different mechanisms which can happen. So we see here that the process conditions influence the kinetic behavior and therefore influence what kind of products you will get. And what makes crystallization, sometimes challenging, but also very interesting. If we start from thermodynamic aspect, you can get extremely complicated phase diagrams, and we don't always have our phase diagram, but if you have your phase diagram, it will help designing the proper process, checking the kinetic. And then in the industry, you can encounter many different types of equipment. So you have a basic stir tank, or you can have forced circulation for continuous crystallization. We can have tea mixer, so you mix things together before going into a reactor. You can have oscillatory baffle crystallizer, and depending on what kind of production, from few kilo per year to several kilo per hour, you can choose different operation conditions. And for those who are interested and want to start somewhere, I think this is a very good book, which can give the first insight into this theme. And now, what is the contribution of chemical engineers in that field? I mean, chemical engineers, you learn to do heat and mass balance. You know how to mass transfer, sorry. You learn how to do mass balances, steering, designing of equipment, optimization of existing equipment for all kinds of unit operations. And for the crystallization step, it's extremely important to have it also combined with anything related to particle technology, to know what happens at the crystal level, to know what happened with the suspension, how to transfer suspension, and what can happen at the level of product properties. And therefore, also the mass balance doesn't tell you if you have one particle of 1 kilo or 1,000 particles of 1 gram. So population balance is extremely important. And what also is here are different crystals. You see, you have all kinds of shapes. So we have a lot of development needed in how to characterize properly crystals, but especially online, because when you take samples, that's also a difficulty. So yeah, this is really to highlight the variety of crystallization from the fundamentals. So there's still a lot going on. So with this, I think I hope I could give a first insight, easy insight into the world of crystallization. Yeah. And and then I think from industry, it's important to be in relation to the development in academia, and that's why we have the working party, and that's why it's now I will transition to Daniele. He will tell you about the working party of crystallization and what are our activities.
Yes, thank you very much, Elodie, for the very nice and clear presentation. Just double checking that you can see my screen and you can see the right part of my screen.
Yes.
Good. All right. So as Elodie explained, we have this working party. So these working parties are thematic groups within the European Federation of Chemical Engineering, covering many different topics. And the one Elodie and I belong to is the Working Party on Crystallization. So I have been chairing this working party since 2021. I'm towards the end of my term, and I will probably chair the working party for another 4 years. So what is the structure of the working party? We have delegates. So delegates are people delegated, nominated by the member societies of the European Federation of Chemical Engineering. We have 2 delegates from Germany, nominated by DECHEMA, 2 members, for example, from Italy, from IDIC, which is the Italian Association of Chemical Engineering, and then 2 members from France and from all the other countries member of the European Federation of Chemical Engineering. In our working party, we like to have 2 delegates with different backgrounds. So we have 1 from industry and 1 from academia. Since I started chairing the working party, I also pushed a lot the idea of having the community vibrant and diverse. So we also have elected members, which are not delegates, but these are people who we want to be part of the working party, contribute to the life of the working party, and are elected every 4 years. So in doing that, we have been trying to reach out to people and research areas that otherwise would not have the right exposures. At the moment, we have 22 members from Belgium, France, Italy, and the other countries that are listed here, plus a number of elected members, as I said, and guest members. Guest members are members working in countries which are not part of the European Federation of Chemical Engineering. What do? We basically organize events, foster collaboration, stimulate interdisciplinary discussion on traditional research lines, which have been highlighted by Elodie before, crystallization fundamentals, investigating thermodynamics, kinetics, nucleation, growth, aggregation, and breakage, but also crystallization modeling and control, crystallization design and optimization. And then we apply this fundamental knowledge to a number of practical applications. So there are a number of applications which are historically very important for crystallization, and these are pharmaceutical industry, food, agrochemical industry, but also the fine chemical industries, plus a number of emerging research lines. For example, better control and online monitoring of crystal size and morphology, also with machine learning and artificial intelligence tools, application of crystallization to new problems, for example, freeze drying, crystallization and precipitation of biomolecules. So there is this growing field of biopharma, which involves many crystallization processes. Crystallization and precipitation for battery material production and battery recycling, and then of course crystallization for sustainability, sequestration of CO2, reducing the impact of anthropic activities on greenhouse gases emission, and reducing the impact of crystallization processes on the environment and on the emission of CO2. What are the main things that we do? We organize events. So we have one event that we really care a lot about, which is called the International Symposium on Industrial Crystallization. The last edition was held in 2023 in Scotland in September, and it was held in conjunction with a meeting of the British Association for Crystal Growth. The next one is going to be in September 2026 in Budapest, in Hungary. Besides the ISIC, the International Symposium on Industrial Crystallization, we also organize a number of collateral events. For example, we have special sessions at the European Congress on Chemical Engineering. We didn't have many at the last conference, which was held in Lisbon only a couple of weeks ago. But for example, we organized a special session in the edition in Berlin in 2023, which was called the Pharma Challenge. We also organize webinars in the context of the Spotlight Talks of the European Federation of Chemical Engineering. In 2024, we organized one on machine learning and artificial intelligence for crystallization, and in 2023 we organized another one on innovative characterization techniques for particulate and crystallization processes. In 2022 we had one on battery recycling, so very different teams. In 2024, we did organize also a number of additional events. There was a very nice meeting organized in Torino by Elena Simone and myself. Elodie was also part of this meeting. The meeting there focused on crystallization for small molecules, and it included a number of talks from industry and academia. Something else that we do, which again is very important to us, is the organization of summer schools. Traditionally, this is something that we organize every other year. So the last one was organized in 2024 in June in the UK. It was hosted by GSK, the pharmaceutical company, in Stevenage. The one before was in 2022. At TU Dortmund in Germany, again in June. The one planned for 2020 was for obvious reason for the pandemic cancelled, and the one before was organized in Italy in 2018. The next one will be in 2026 and will be organized in conjunction with our ISIC meeting in Budapest, Hungary. So those of you who are interested in attending this school, please let me know. The last thing I want to say before closing this short introduction is that we also sustain a crystallization award, which is given to a young researcher due to the PhD thesis or a number of publications. And these are the people who won the award in the last 3 editions. In 2023, it was Francesca Breveglieri from ETH Zurich. In the edition before, 2020, delivered in 2021, was Ashwin Rajagopalan, who obtained his PhD from ETH Zurich, but is now a lecturer, senior lecturer, I think, at the University of Manchester. And in 2017, it was Elena Simone, who is a colleague of mine now. She was back then in Loughborough for her PhD. She was a lecturer in Leeds and is now a full professor in my department. So again, if you are interested in, if you want to learn more, go to our website and you will see how this crystallization award works and what you have to do to, for example, candidate yourself.
So thank you, Dr. Elodie and Professor Marquesio for this informative presentation. So we will continue with the interview part, and the interview part is composed of the questions prepared by EFCE Early Career Chemical Engineers section. So let me start with first question. For someone new to the field, how would you explain the importance of crystallization in both academia and industry? And also what makes it unique compared to other separation processes, and how it contributes to other products we encounter in daily life?
Who wants to start?
Well, I can start. I mean, yeah, you've seen that it's quite a, I mean, it's a unit operation. It's one unit operation, but a lot happens during this unit operation. And there's still a lot which, yeah, and we can really tune the final product with this separation technique. So it has a huge influence on the final product. And so that's why it's important for industry. But I think for academia, there's still quite a lot to be developed in terms of characterization techniques, modeling, because yeah, when you start with a new molecule, you can still not predict how it will behave. So you still need a lot of experimental work around it. So I don't know, Daniele, do you want to add something?
Yeah, maybe I'll add something about the, how crystallization contributes to the production of products that we encounter in our daily life. So my PhD was about modeling, and I was back then interested more in fluid flow and mixing rather than crystallization. So I happened to choose crystallization as a possible application. And so only later I started, studying crystallization. And I was surprised to see that many of the things that we use every day are powders made with through crystallization. So for example, I do a bit of cooking. Most of the powder that we use during cooking are produced with crystallization. I also do a bit of gardening. Most of the powder that I use either to fertilize the garden or to kill some of the bacteria and then fungi and insects that travel around the garden are produced with crystallization. And the same applies to medicine and drugs. Every time we take a tablet, most likely the powder that was done for producing the tablet was done through crystallization. So it is really everywhere.
Thank you for your responses for the first question. So let me continue with the second question we prepared. What skills and chemical engineering knowledge should a young researcher develop to work in crystallization, and what career paths can this specialization lead to?
Elodie, maybe you can also start. I'm, more interested in your answer than mine.
Mm-hmm. Yeah, I think in terms of skills, I mean, good understanding of chemical engineering, but also a lot of curiosity about many other fields, because you really need to connect with people from thermodynamic, from the particle technology part. You need to, so it's really, or with regulatory when it comes to getting a new product on the market, or so really open-minded and curious. And one thing through the years of experience, every time we get a new process to work on, we have new things we need to think all new. So we need to adapt constantly to make it efficient. So that's, those are the skills. And career path, I think there are many options. It can be as a research, as a project development, or in production. People who have been working on crystallization and go to industry will certainly make a good impact because they contribute to something which is important. So Daniel, if you want to extend.
Maybe I'll elaborate a bit more on chemical engineering knowledge. So it really depends on the final application and the molecule that you want to crystallize and the process. In some cases, thermodynamics is really important. So being able, for example, to understand a phase diagram, a complex phase diagram with 3 components, for example, is really important because otherwise you will not be able to, to figure out how the process works. This is particularly important now in this moment in which we are transiting from crystallizing small molecules to crystallizing larger molecules, in which these phase diagrams become incredibly rich. So a solid understanding of thermodynamics is really important. And the other thing that you really need to know is the basic physics and chemistry of dispersed systems, nucleation, classical nucleation theory, growth, aggregation of particles, breakage. These are things that you really need to know. Everything else, I think, can be learned afterwards, but without a solid basic knowledge of thermodynamics and kinetics, I think would be difficult to build a career in this topic.
So thank you for your response for the second question as well, and Sena will continue with the questions, the rest.
Thank you, Alper. Our next question is, in the context of computational fluid dynamics, CFD simulations applied to crystallization, which platforms do you consider most suitable? For instance, ANSYS, Fluent, COMSOL, or open source tools such as OpenFOAM?
Maybe I can start on this one, since this is like my personal obsession. So again, also in this case, it really depends. Both tools are extremely useful and important. Open source tools, because they are open source, are very flexible. So you can, add equations, modify the equations, make them extremely more efficient, completely change them. So for example, OpenFOAM is not only an open source platform, but is also a sort of programming C++ platform in which you can do whatever you want. On the other hand, these open source tools have very steep learning curves, so it is very difficult to use them, to learn how to use them. Commercial codes typically are easier to use because they have a very easy and nice graphical user interface. They also have additional tools that make it easy to build the geometry, build the mesh, export new physics. But of course, you are bounded to something that the code gives you. So you have less freedom and less flexibility. But both are extremely important, and it's very nice that both in academia and industry, we have the opportunity to play with both tools.
Thank you so much for your insightful answer. The next question is...
Maybe you wanted to add something on this, or...
we're actually personally here, we do not use too much modeling, but we're looking at the developments because we know what it would be able to bring. But you mentioned there's a steep learning curve. So if people have never worked on it and have no knowledge on crystallization, and we were working on processes which have been running for many years. So if we want to go a step further in optimization, I think at one point this modeling will be helpful tools, and we probably will then make collaborations with university to step in. But I think where they are really important is they help understanding what can happen, and without doing experiments, you get an idea and a feeling about the different kinetics and influencing parameters, and give you indication in which way you can develop your process. And but we are personally here in the company not using them at the moment, but keeping an eye on the developments.
Thank you so much. The next question is, what are the main challenges in scaling up crystallization processes from lab to industry?
Well, I think through the, well, you see that there are so many mechanisms happening. And if you, I remember learning how to use dimensionless numbers, but in the, for crystallization, very often you have conflicting, so you need to keep your dimensionless numbers, but for one specific application, you might need to lower, if you, depending on what you want to achieve, you might need to lower the steering rate, but then you cannot suspend anymore to minimize the attrition and so on. So then when you come to larger scale crystallizer, you have to take into account the fact that it might not be homogeneously distributed and perfectly distributed. So there, actually, there the help of CFT can support what you do. So I think, yeah, doing a proper scale up or scale down, yeah, you need to take this into account, this multi-scale. What happens at the molecular scale can actually influence what happens in a larger scale equipment.
Yeah.
That makes
I
it
agree.
difficult.
I agree, nothing to add, yes.
Thank you for your answers. We can continue with our audience's questions. You can share in the chat, or you can share your questions with us in our LinkedIn account. So thank you again for all of your answers. I'm giving the floor to Alper now.
Yeah, so if we have questions from Q&A, we could take this, we exceed a bit of time, but let me check. Currently, we don't have any questions. Ah, yeah. How can Vandana, could you write your question on Q&A box? If right, we will appreciate it. I think she's unmute. Yeah, let's unmute the maybe. Yeah. The question is, hi, among different crystallization techniques available, how to decide which ones we select?
Yeah, I can do that. Well, I actually will, if you have, yeah, it depends what you want to achieve. Is it, do you want to, well, you can screen and see how your, you need to find a, you need to find a process where you have at the beginning high solubility and at the end low solubility, so that you can create your solid. So if you have a molecule which has a increasing solubility with temperature, then probably cooling crystallization will be the right way. If you have a, it depends also in which solvent you're working upstream, if you have a reaction before, etc. So it really, yeah, I don't think it will be product dependent and dependent on the objective you want to achieve. Daniele, you might want to give more details there.
Yeah, no, I agree with what you said. It really depends on the product, the solvent, the dependence of the solubility over the temperature. Maybe something else, if we still have time, that I can add, which does not answer to this question directly, but it's maybe an important piece of information, is that there are also, crystallization can also be an unwanted process. So, for example, fouling and scaling, which is very important in heat transfer operation, the formation of fouling and scaling, due to the fact that some salts have a solubility that decreases with temperature rather than increasing, is an important industrial problem, and it is at the end crystallization. So in this case, you also need to know all the things we discuss about crystallization, nucleation, growth, aggregation, and breakage, but to avoid crystallization rather than promote it or to control it if you want.
So thank you for your responses. And as we previously mentioned, you could ask our questions on LinkedIn page as well after the meeting, and our speakers will reply to your questions as well. So since we exceeded our time, thank you for joining us for today. So, and also thank you, Professor Marquez and Dr. Verdurand, for accepting our invitation and joining our first Coffee Talk events under European Federation of Chemical Engineering, Early Career Engineers section. So thank you. Yeah.
Thank you very much. Thank
Yeah,
you all
thank you
for
very much
organizing this.
for
Yeah.
organizing.
Thank you.
Thank
Have a
you very
nice
much.
day.